Hello, my name is Weston. This is my math project on designing an experiment and confounding variables. I will be teaching you guys how to do this alongside with my assistant Jeffrey. So in this we will be talking about what is an experimental design and a confounding variable. What to expect throughout is what experimental designs are and how they work and when to use them. Our mission and vision is students will be able to learn and identify the difference between a random design and a group design. And overall, experiments use random assignment, comparison, control, or replication to test treatments. As you can see here, Jeffrey is pointing out each one. He can be a very helpful guide throughout this. So what is an experimental design and confounding variable anyways?
I don't know.
Up the top right, we have a question: does drinking coffee in the morning help students stay more focused during first period class? An experimental design is the plan for how you run an experiment. It's how you assign subjects to different treatments, control other factors, and measure results so you can fairly test cause and effect. A confounding variable is an outside factor that affects the results and is unevenly distributed between groups, making it hard to tell if the treatment actually caused the outcome. So how does this apply to the question? An experimental design tests coffee versus no coffee on focus, but a confounding variable like already drinking coffee can affect results. Breaking down an experiment. There's 4 principles that come with it. There's the comparison, the random assignment, the control, and the replication. The comparison is without a second group to compare against, you have no baseline. You need at least 2 groups, usually a treatment group and a control group, gets nothing or a placebo. There's a random assignment, which is the process of using a neutral method like a coin flip or a random number generator to decide who goes into which group. Then there's the control. This means keeping all environmental factors the same for both groups except for the one variable you are testing. And then there's the replication, having a large enough sample size within the experiment. Here's Jeffrey comparing all the ones and make sure what's in order. Thank you, Jeffrey. So, using confounding variables. Remember, a confounding variable is something that could affect the response and is unevenly distributed between the treatment groups. So, the teacher wants to test coffee, it gives better focus. But many students already drink coffee every morning before school on normal days. This is a potential confounding variable, as demonstrated by Jeffrey. A possible confounding variable is already drinking coffee. The possible confounding variable is it affects focus level, and already drinks coffee may end up uneven in the 2 groups. So, a randomized design. Why do we use this? We use this because random assignment is our best defense against bias. It ensures the only systematic defense between the groups is the treatment itself. So for this, does drinking coffee in the morning to help students stay more focused during first period class, we would take all 40 students, we would use a random assignment to split them into groups of 20, and one group would be drinking coffee before class, and group 2 would be drinking water, which is the controlled group. So with this, we can describe it as so. Number the 40 students 1 to 40, use a random number generator to select 20 for the coffee group, the rest go to the water group. For group design, we use this when you know a variable that is likely to affect the response and could confound the results. So how would you make a group design? Well, first you would form blocks based on the confounding variable. Group 1, students who already drink coffee regularly before school. In Group 2, students who do not drink coffee before school. Then you would randomly assign treatments within each block. Block 1, randomly split the 22 into 11 coffee and 11 water, and Block 2, randomly split the 18 into 9 coffee and 9 water. So, blocking controls the confounding variable by making sure that both treatment groups have roughly the same proportion of regular versus non-coffee drinkers. And it also reduces extra variability, which makes it easier to see the real effect of the treatment. So here's the practice question. A researcher wants to investigate whether a new fertilizer A, increases the growth of tomato plants compared to the standard fertilizer B. She has access to 60 young tomato plants that vary in their initial soil quality. Some are planted in high quality potting soil and others in lower quality garden soil. The response variable will be the height increase in centimeters of each plant after 6 weeks. Part A. Describe a completely randomized design for this experiment. Include how the researcher should randomly assign the treatments, fertilizer A or B, to the 60 plants. Explain how this design helps control for confounding variables. Part B. Soil quality is a potential confounding variable because it could affect plant growth independently of the fertilizer type. Describe a randomized block design, also called a grouped or a block design, that uses soil quality as the blocking variable. Clearly explain the steps, including how to form the blocks and perform random assignment within blocks. Part C. Explain one advantage of using the randomized block design over the completely randomized design in this situation. Also, explain why assignment is still important even when blocking is used. Part D. Suppose the researcher that the plants also vary in the amount of sunlight they receive. Some are in full sun, others in partial shade. Is sunlight another potential confounding variable? If so, suggest how she could incorporate it into the experimental design, or explain a limitation if she cannot easily block on it. Give it a couple seconds. Alright, so for part A, we have a controlled random design controls for confounding variables by randomly assigning subjects, thereby balancing other factors between groups. This makes difference in growth more likely due to the fertilizer itself rather than outside influences. Part B. First, you form blocks based on soil type. Then identify all the plants in high quality soil and create one block. Make another block with low quality soil within each block. You would randomly assign half the plants to fertilizer A and the other half to B. Part C. Using a randomized block design reduces variability, form soil quality, making differences between fertilizers easier to detect. Random assignment within blocks still spreads other confounding factors evenly between groups. Part D. Yes, sunlight is another potential confounding variable. If plants in full sun tend to grow more, regardless of fertilizer, and by chance, more of those plants end up in the fertilizer A group. Sorry for all the misspelled words throughout the project, but this is the end of my lesson.